Hi, and welcome back to Algebra 1 Summer School for Semester 2. This is Day 8. Today's objectives are to identify if a pattern, graph, or function is linear, quadratic, or exponential. So we're going to be kind of looking at some notes and kind of bouncing back and forth. We'll be probably doing a considerable amount of this together, but just kind of pay attention, follow along, and we'll get started. Okay, to identify from an equation whether the graph is linear, if it's linear, the x has no exponent. So we just have a plain old ordinary x, a plain old ordinary x, a plain old ordinary x. Y is also plain and ordinary. So has both x and y with nothing else going on besides multiplication in there. For a quadratic equation, you're going to want to look for an x squared in your equation. So there's the x squared in the first equation, there it's sitting in the second equation, there it is in the third equation. Y is normal without any exponents on there in order for it to be a quadratic equation. So we have a regular y. For exponential, we still have that regular y, but now x is the exponent. So with this quadratic, the x is the base, but with exponential, x is now the exponent. So when you see x up there as the exponent of a numerical base, that's when you're going to have an exponential function. So take a minute, pause the video, let's do a check for understanding. I'd like for you to try examples 1 through 4. Identify if they are linear, quadratic, or exponential. Pause the video now. When you're ready, you may resume. All right, in example number 1, the x is the exponent, which means that this is exponential. In example number 2, x is the base, and the largest exponent I see is 2, which means that this is a quadratic. In example 3, x is a base without any exponent, so this is linear. And in example 4, x is the exponent, which makes this exponential. All right, some characteristics of graphs for these functions. If it's linear, it makes a straight line. It has a constant growth all the way across the page. For quadratic graphs, this makes a parabola. So it's a shape that goes, kind of looks like a U as you're looking through the graph. With an exponential, it's going to rise or fall quickly in one direction. So you kind of get this like L-looking shape. It could be either this sort of backwards looking L or forwards looking L or backwards looking L, just depending on whether it's growing or falling. So let's do is check for understanding. There are 3 functions at the top of the page. I'd like for you to identify if they are linear, quadratic, or exponential. When you're ready, come back and we'll go talk through them together. So go ahead and pause the video and try now. Okay, in example 1, we have that U shape. That is a parabola, which means that this is a quadratic function. In example B, this starts up high and then falls as it goes to the left or to the right. This would be exponential. And C is a straight line, so this is linear. All right, let's take a look at a table. So when you are looking at a linear value, you are never going to see the same y value twice. Nothing's going to repeat. And the first difference between the outputs is the same. So what that means is if I look at the difference between these two values, 1 minus negative 1 means we added 2. To get from 1 to 3, we added 2, and from 3 to 5, we added 2. So because these are the same, that indicates that this is going to be a linear function. When you write a linear function, you're going to have that change times x plus your y-intercept, which happens when x is 0. So the change in this graph is 2, the y-intercept happens at 1, so our equation would be y equals 2x plus 1. All right, for a quadratic function from a table, you're going to see the same y value more than once, especially if you extend your table in both directions. It's possible that you won't see it right away, but if you continue looking through the table, you're going to start seeing some things repeat. So like -2 and 0 have the same output. The second difference is the same. So what that means is the first difference is going to be how these are changing. So we went down 1, up 1, up 3, up 5. This is that first difference. Then what we can compare is that second difference. So from -1 to +1, we went up 2. From +1 to +3, we went up 2. From 3 to 5, we went up 2. This is that second difference, which is the same. So this would be a quadratic function. All right, with an exponential function, you're never going to see the same y value twice, and you're going to see a common multiplication pattern in the y instead of an adding pattern in the y. So if you look, 1 times 2 is 2, 2 times 4 is 2, 4 times 2 is 8, 8 times 2 is 16. So you have the same multiplier there. When you're writing exponential functions, you're going to have y equals your y-intercept times that change to the x power. So in this case, my y-intercept is 1 times my change is 2 to the x. So this is y equals 2 to the x. All right, that's the big ideas for today. The lesson is short and sweet, to the point. Please make sure that you submit everything in Google Classroom and take the formative assessment. Please reach out if you need help. I'm happy to help in any way I can. Thanks, guys. Have a good afternoon. Talk to you later. Bye.